is a problem about some sort of shipping container or something. A rectangular storage container without a lid is to have a volume of 10 cubic meters. So it's a big box, right? The length of its base is twice its width. Material for the base costs $10 per square meter, and material for the sides costs $6 per square meter. Find the cost of materials for the least expensive such container. Okay, so there's a lot of different stuff going on in this problem. I'm going to start with just sort of thinking about, okay, they're saying the least expensive, I'm supposed to minimize some kind of cost, right? So I'm supposed to minimize the cost of the container. And the cost is going to depend on the dimensions, right? So first of all, let's figure out what our box looks like. So you can just think about this like this, right? Like an empty box without a lid, like a shoe box, right? So if I have some just general box, sorry, it's such a bad drawing, we've got length, width, and height, right? We know that the volume is length times width times height, so we have that information. We know they actually told us something else. They told us the length of its base is twice its width. So length is 2W. So my drawing isn't very good, but okay. So they told us that. They told us that the volume is 10. All right. And then they're going to tell us the material for the base costs $10 per square meter. And the material for the sides costs $6 per square meter. And remember, it's an open top, right? So if I think about the cost of the materials for making this, I've got the 4 sides times the base, right? So I can write down the cost. First of all, I'm going to write down the cost because that's what I know I'm going to minimize, right? So I'm going to write down the cost in terms of this length, width, and height. Right? W, L, H, 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 right? So, the cost is going to be $10 times the area of the base plus $6 times the area of the sides, right? So just being very general. So the area of the base is length times width. And the area of the sides, there's 4 of them, right? And they're not all the same because these 2 are length times height, and then there's 2 that are width times height, right? So if I just go around and look at that, my 4 sides, it's not a square. In fact, they told us that because they told us that length was 2 widths. So it's not a square. So you have 2 different parts. You have one short side and one long side. But there's 2 of each of them, right? So 2 length times height plus 2 width times height. Maybe there's too many of these on there. It's hard to tell. All right, so does that help? Maybe more helpful? I don't know. Anyhow, that's the height there. So anyway, so that is going to be our cost. So this is what we need to minimize. But we need it, so that's fine, that's good. We need it in terms of one variable, right? And so we can do a couple of things. We have length equals 2 width. So I can get rid of that, right? And I'm just going to do it in 2 steps. So this is going to be 2 width squared plus 6 times 4 width height plus 2 width height, right? So that gives me 20 width squared plus, what is this, 6 times 6, 36 times width times height. Great. So now I still have to eliminate the h. But at least I've gone down first from 3 variables to 2 variables. Now I'm going to eliminate the h. What I'll have to use, I've got this volume thing. So, in fact, it was helpful to me in terms of solving the problem that I drew my picture And then before I started setting everything up, I just sort of went through and wrote down the information that they gave me, sort of willy-nilly, but at least I know where it is because now I can go and use it. So here I got volume is length times width times height is 10, right? So I need to get rid of still the length. So it's going to be 2w squared h equals 10, right? Once I put that one there. And then I get height is 10 over 2w squared, okay? So 5 over w squared, let's put that in here. 36w times 5 over w squared. So finally, after all of that, the heck is 36 times 5? 180. All right. So I have 20 width squared. I'm going to rewrite this so you can see it, but anyway, I got that. All right, so cost then turns out to be, after doing all of that, 20 width squared plus 180 over w. Okay, so it turns out that I had it in terms of width, and that's fine. As I said, it doesn't really matter which variable. Okay, so now I'm going to find the minimum, right? So I'm going to take the derivative and find the critical points, set equal to 0, all that sort of thing. So the derivative, I got 40w minus 180 over w squared, right? So, w squared, 40w cubed minus 180. Thank you very much. All right, so anyhow, so we have that. Now listen, so first of all, we've got two issues. Of course, we've got the part of the critical point where, okay, the w equals 0, right? But w equals 0 obviously would be like an infinite cost. So that's some sort of crazy maximum, right? We don't care about that. But just thinking so that it's there, well, the other part we have is that top, right? 40w cubed minus 180 equals 0. 9, right? Right? So w cubed is 9 halves. W is the cube root of 9 halves. That's great, whatever that is. Okay, plus minus, of course, right? But I know it's not plus minus, of course, because it's cubed. Never mind. It's that. All right, so that is our point. Let us double check. Is this in fact a minimum? It is the cube root of 9 halves, right? Well, that's bigger than 1, right? So it's going to be negative here. And if I put in something that's really big, obviously it's going to be positive here. So this is in fact the minimum point, okay? Great. Now here's the question. So I found my minimum W. Now the question is, how I'm done? I'm not done. I have to answer the question. It says find the cost of materials for the least expensive such container. So I still have to go back in here and put that point in here, right? So I found my minimum point, but that doesn't tell me the minimum dollar amount, right? So I'm going to put that in here. So the cost at cube root of 9 halves, whatever this is, right? Which is